Welcome to section 12.8, contrasting and relating the perimeter and area of shapes. Remember to complete the problems with me and the you-tries and explorations on your own. Here are the topics, skills, and understandings. We're in grades 3 and 4. And if we know the distance around a shape, can we determine its area? And if you know the area of a shape, can you determine the distance around it? And what is the difference between perimeter and area? Children learn about area and perimeter and the distinction in elementary school, but as we dive a little bit deeper, we can see that the relationship is actually a little more advanced. So students often get confused when deciding how to calculate perimeter and area. Okay, so that is a big confusion in your future classrooms potentially, because we add to calculate the perimeter and we multiply to calculate the area. And when we calculate the perimeter, we add all 4 sides. Or you could do 2 sides and multiply by 2, but for area, we multiply only 2 sides. And so it's hard to keep all these different methods straight unless we actually have a really clear understanding of what perimeter and area mean and how they're different. And although they are different, there is a relationship. And so when you are teaching this in your classrooms, making sure students have that understanding with explorations, with hands-on activities to make sure that they get it rather than just, hey, here's the formula, this is how you do it. So why do we add the lengths of the sides of a polygon to calculate its perimeter? So the perimeter of a polygon is the distance around. Remember that. So a hands-on way to think about perimeter is a length of string that wraps snugly once around the shape. And when we calculate the perimeter of a polygon by adding the lengths of the sides, it's as if we had to cut the string into pieces and are just determining the total length of the string by adding up the lengths of the pieces. So it's a really nice concrete way to make sense of that. We do have explorations in this section, so remember, don't skip these. Take the time, get the supplies, spend the time to uncover the material before it's taught to you. Complete this exploration and then press play when it's all done and you're ready to move on. So the difference between perimeter and area. So if we look at this shape, the perimeter is 26 centimeters, and you can see it over here. We calculate the length of each of these, 1, 2, 3, 4, and so on. But the area is 21 centimeters. So the perimeter is described by a unit of length, and the area is the unit of area. So we've got square centimeters versus centimeters. And the perimeter is the number of 1 centimeter segments it takes to go around, all the way around. And in the area is the number of 1 centimeter by 1 centimeter squares. So we could, instead of counting these, it could be 1, 2, 3, 4, 5, 6, and this is the area. That would be a way to calculate the area. So now, again, you've got an exploration. I do encourage you to use string for this one and to use grid paper. There is grid paper in your textbook on page CA 258 or any graph paper, and press play when you've completed this entire activity. So if you did the explorations, you discovered that for a given fixed perimeter, there are many shapes that can have that perimeter. So if you know a perimeter, there are many shapes that can have it, and they can have different areas. So perimeter does not determine the area. But for a given fixed perimeter, there are certain areas that can occur and certain areas that can't occur. There are limitations or constraints on how big the area can be within a certain perimeter. So let's just look at rectangles. If you did it, you saw that all of the rectangles, the largest area was the square. The greater the difference between the side lengths, the smaller the area becomes. So if you kind of took a look at this, if these differences were like 5 and 5, the difference is like nothing, right? But if the differences here, well, those aren't going to be the same, but if we had like 5, 10, 15, 20, 1, and 19. So that has a really big difference between the side lengths, and then that is going to end up with the smallest area, where this area is 25 and this area is 19. That can help you kind of make sense of that. One way to deal with this is to take your, to look at a perimeter of 24 inches and a square that has side lengths of four side lengths of 6 inches, And so it'd be 6 by 6. So they did it 6 by 6. 6 by 6. And you get 36. And if you were to take a 24-inch loop of string and form a ton of rectangles, you would see that it would be every positive number less than 36. And so that's true. That square shape is your biggest area. And so everything is going to be smaller than that. So among all rectangles, the square with that perimeter has the largest area, and every positive number that is less than the area of that square is the area of some rectangle. And we're not going to prove that. It kind of goes beyond the scope here, but we are going to do some examples. So if we kind of consider all shapes with a given fixed perimeter, then maybe you have this idea that the circle will be the largest area. So if we have all shapes with a perimeter of 15, which means the circumference is 15, then that means the circumference of this circle is 15 inches. So it's radius. So again, they're doing this calculation. If we know that the circumference is 15, we can calculate 2 pi r. We can figure out the radius by dividing both sides by 2 pi, which is what they're doing here. And they're telling us, okay, that's about 2.4. So the area would be pi r squared. So in this case, they're keeping this as the radius, 15 over 2 pi squared, and they get about 18 inches. So if you have a 15-inch loop of string and you start moving it around on your paper in various, you might think that every positive number less than 18 is the area in square inches of some shape of perimeter 15 inches. So for example, there is a shape that has a perimeter of 15 inches, remember that's what we're talking about, and an area of this amount, and an area of this amount. But our maximum is going to be that 18 because that's our circle, that's our biggest one. And we can say that without actually finding it, but to prove that would be beyond the scope here. So among all shapes, given a fixed perimeter, the circle of the circumference has the largest area. So we know that it's going to have the largest area as our circle. Let's make sense of this a little more. All right, so Anya wants to draw many different rectangles that have a perimeter of 16 centimeters. She draws a few, but then she stops drawing and starts looking for pairs of numbers that add to 8. Why does it make sense for her to start looking for pairs of numbers that add to 8? And how is she likely to use these pairs of numbers? All right, well, we know that she's drawing rectangles. So we've got length times width. So we know that the perimeter is 2 times the length plus the width, right? We would say like L plus W plus W. So that's 2L plus 2W. It's just 2 times the length and the width. And so she's basically saying, okay, her perimeter is 16. So if she is doing 8, that is, she's trying to say, okay, if I can find side lengths that add up to half of the perimeter, then I'm going to get it. She wants to add up sides that add up to half of the perimeter. Sides that add up to half of the perimeter. And that's where she came up with that 8. How could you adapt if you were going to draw many different rectangles that have a perimeter of 14 centimeters? Okay, so we know that the perimeter is 14, and we know that it's going to be length plus width. And we want to add these numbers here. Well, 2 times what is going to get us to 14? So we want to find sides that add up to 7. That's going to make it a lot easier for us. Use Anya's idea to help you draw 3 different rectangles that have a perimeter of 5. So if we have a perimeter of 5, then we want to find sides that add up to, oh boy, well, 2 times 2.5. So we could do, let's pick 3 different ones. We could do 0.5 and 2. That adds up to 2.5. We could do 1 and 1.5. And we could do 0.7 and 1.75. Lots of different options here, right? So that might be like this, 0.5 by 2. That might be like this, 1.5. And that might be like this, 0.75, 1.75. We'll pause here. We'll do a couple more examples and some you tries when we come back in the next video.